In our previous session, we had seen turning flight. Let us move on to Venn diagram in this session. The operating flight strength of an aeroplane is represented in the form of Vg or Vn diagram, where V denotes airspeed and G or the N denotes the load factor. We might find a Vg diagram in our flight manual if we are flying a high-performance fighter. The Vg diagram leads to cornering speed that allows us to extract maximum performance from our aircraft without breaking it. The operating flight strength limitations of an aeroplane are represented in the form of Venn diagram. This chart is usually included in the aircraft flight handbook in the session dealing with operating limitations. The Venn diagram represented is intended to present the most important general features of such a diagram and does not necessarily represent the characteristics of any particular aeroplane. Each aeroplane type has its own particular Venn diagram with specific V's and N's. The flight operating strength of an aeroplane is represented on a graph whose horizontal scale is airspeed V and a vertical scale is load factor N. The representation of aeroplane strength is contingent on four factors. First, the aircraft gross weight. Second, the configuration of aircraft, clean external stores, flaps and landing gear positions. Third, symmetry of loading, since a rolling pull-out at high speed can reduce the structural limits of approximately two-thirds of the symmetrical load factor. Fourth, the applicable altitude. Any change in one of these four factors can cause important change to the operating limits. Load factor is given by L by W is equals to half rho V infinity square SCL by W. The maximum load factor is a function of maximum lift coefficient and is given by half rho V infinity square CL max by W by S. Further, in the graph, we can see that point A is the maneuver point where load factor and the lift coefficient are at its highest possible values. The velocity at this point is called a corner velocity, which is given by root of 2n max by rho infinity CL max into W by S. Graph provides the supplementary information to illustrate the significance of the Venn diagram. The lines of maximum lift capability are the first point of importance on the Venn diagram. The subject aircraft is applicable of developing no more than one positive G at 100 knots, the wing level stall speed of the aeroplane. Since the maximum load factor varies with the square of the airspeed, the maximum positive lift capability of this aeroplane is 4G at 200 knots, 9G at 300 knots and 16G at 400 knots, etc. Any load factor above this line is unavailable aerodynamically. That is, the subject aeroplane cannot fly above the line of maximum lift capability. Limit airspeed is the design reference point of the aeroplane. The subjected aeroplane is limited to 575 knots. The aeroplane must be operated within this envelope to prevent structural damage and ensure that the anticipated service life of the aeroplane is obtained. The pilot must appreciate the Venn diagram as describing the allowable combination of airspeed and load factor for safe operation. There are 2 points of great importance on the Venn diagram. Point B is the intersection of the negative limit load factor and line of maximum negative lift capability. Any airspeed greater than point B provides a negative lift capability sufficient to damage the aeroplane. Any airspeed less than point B does not provide negative lift capability sufficient to damage the aeroplane from excessive flight loads. Point A is the intersection of positive limit load factor and line of maximum positive lift capability. The airspeed at this point is the minimum airspeed at which the limit load factor can be developed aerodynamically. Any airspeed greater than point A provides a positive lift capability sufficient to damage the airplane. Any airspeed less than point A does not provide positive lift capability sufficient to cause damage from excessive flight loads. The usual term given to speed at point A is the maneuver speed, since consideration of subsonic aerodynamic would predict minimum usable turn radius to occur at this condition. The maneuver speed is a valuable reference point since an aeroplane operating below this point cannot produce a damaging positive flight load. Any combination of maneuver and gust cannot create damage due to excess load when the aeroplane is below the maneuver speed. By this, I hope you would have understood Venn diagram. By this, we come to the end of Introduction to Flight. See you in the next course. Thank you.